So I think did we do one last class or did we stop right before? I can't remember. One class I did do one and one class I didn't. We stopped before. Okay. Section 3.3, it's called piecewise functions because you're breaking it into two parts or more. It could be more. But if x is less than or equal to 0, it could be one thing, and if x is greater than 0, it could be another. And so it's looking at more than one part. Stamps are kind of like that. It costs one price, but then at a certain weight, it jumps to another price and goes, and then jumps to another price and goes. And so stamps are used a lot with piecewise functions. When we're putting it into Desmos, there's two different ways you can enter it. I like the second way better, but they both work. You can put the inequality inside script parentheses. You put the inequality and then a colon and then the expression. So it would be x squared minus 1 instead of y equals. Where this one, you put the equation and then you only put the inequality part inside the script parentheses. And script parentheses are next to most computer keyboards. It's next to the P. To the right of it, you hit shift to get them. So we're going to graph these on Desmos, but before we do, I want to make sure you understand how to plug values in. So if we had f of 1, that's when x is 1. Then you look here to see which one it falls into. And in this case, 1 is greater than 0. So it's the bottom one. It will never be both. These will not overlap. So it's one or the other. And 1 is greater than 0. So you use this equation. 1 cubed plus 2 is 3. F of 0, again, we look here. This one has the equal to 0. This one does not. So it's the top one. And then you just plug into the top equation. 0 squared minus 1 is a negative 1. So negative 2 is not greater than 0. It's less than. So it uses this one. So when we plug in negative 2 squared is 4 minus 1 is 3. Any questions on which one to choose? Like the top or in this case, top or bottom equation. Okay, to put it on Desmos, I can put it here. There we go. So first we'll type this first one. Now you can use either one of these formats. I'm going to use the second one. So I'm going to put the equation y equals x squared minus 1. Now for the squared, you can use this button here. You can also use this one, but if you use this one, then after you put the 2, you have to hit the right arrow to come back down. And you can also use the caret, which is by the number 6 on your keyboard. But see the parabola. Remember, x squared is a parabola. Now, according to this, we only wanted x to be less than or equal to 0. So that means from here over. And watch when we put the script in here, the x less than or equal to 0, it's going to take out the other part of the line. So if we put the script parenthesis, you only have to do one. Notice the other one's there. And then you put x less than or equal to 0. X less than or equal to, is on my keypad, 0. Notice it took the right side out. So it takes the right side out. Then you can go, I just hit the right arrow and a space to get the script to come on that one. And let's do the other one. So it's x cubed plus 2. Y equals x, and then I'm going to hit the AB button. Cubed, and then I'm going to hit the, notice it's up with the 3. If you hit the right arrow, it comes back down, plus 2. Oops, I didn't hit 2. 2. No. Huh. Plus 2. There we go. A cubic function looks like a snake. Now, once we put x greater than 0, everything less than 0, this part here is going to disappear. So we'll put our script x greater than 0. Any questions? I mean, we're going to do more, but any questions on that one? Now you notice I have discontinuous written here. It's discontinuous when, if you're tracing your graph, you come to a spot where there's a jump in it. And this one jumps. So up until 0, x equaling 0, it's continuous, but then at 0, there's a jump. And then after that, it's continuous again. So it's discontinuous at x equals 0. You always use the x value. So where x is 0, there's a break in the graph. Any questions on that? Sure, this a little. Let's try this one. So if we're looking for f of 6, do we use the top or the bottom equation for f of 6? Anyone? We'll see here which one it falls into. Is 6 less than 4? No. 6 is greater than or equal to 4, so I use this one. 4 minus 6 is a -2. Any questions on that part? Okay, f of 4. 4 is not less than 4. It's greater than or equal to. You want the part with the equal to. That's what the little line means. So that means we're using the bottom one to find f of 4. 4 minus 4 is 0. -6. Well, -6 is less than 4, so we would use the top one here. -6 minus 4 is a -10. Any questions on that part? Okay, let's graph it. So I'm going to X those ones out. The first one, y equals x minus 4. And then the script parenthesis, x less than 4. Next one, y equals 4 minus x. No, before I enter that one, we have the line here. Notice that's at 4 and it's less than. This way is less than, this way would be greater. So then we do the next one, y equals 4 minus x. It's that line. But then when we put in x greater than or equal to 4, x greater than or equal to 4, it got rid of the part that was less than. This part of the line was erased. So a lot of times if I was graphing these by hand, I would graph that whole blue line that was there. I'd make it all dotted. And then I'd decide what part to keep and make it solid. And then hopefully I had a pencil to erase, but at least if I didn't, it was dotted, so it was not included. Any questions on creating the graph? Okay, now to see if it's continuous or not, we trace it. And we never have to lift up our pencil because this is colored in from the equal to part. And it keeps going. So this graph is continuous. It doesn't have the breaks like the last one did. Any questions on that? Okay. Try a story problem. The formula that gives the wind chill factor for a 60-degree Fahrenheit temperature and a wind velocity V in miles per hour. So they have a formula and you see what temperature it is, and then the wind will make the temperature, it'll feel warmer or cooler depending on what temperature it is. And so this day it's 60 degrees. So it's saying if the temperature is 60 degrees and the velocity of the wind is between 0 and 4 miles per hour, then it feels like 60 degrees. So when they say it's 60 degrees, but it feels like 40, well, that's because of the wind. But if it's between 0 and 4 miles per hour, it feels like 60. If it's 4 to 55.9, and notice the equal to is on this one, so equals 4. This goes up to, but not equal to 4. So from 4 to 55.9 inclusive, you would use this formula. And then if you're greater than 55.9 miles per hour, it'll feel like 41 degrees. So this in here temperature, you use a formula, but then these two stay consistent. Any questions on reading the equation? It's called a piecewise function because it's pieces. Okay, find the wind chill factor for the 60-degree temperature if the wind is 20 miles per hour. 20 miles per hour is our velocity. So decide which one. Notice 0 to 4, 20 is not in there. If we look at this one, 20 is between 4 and 55.9. So we use the middle one. And just plug it into the equation. 0.644 times 20 minus 9.518 square root of 20 plus 76.495. And if you plug that all in, if the wind is 20 miles per hour, it will feel like it's 46.8 degrees. Any questions on that? Find the wind chill factor for the 60-degree temperature if the wind is 65 miles per hour. If the wind is 65 miles per hour, are we using first, second, or third equation? Anyone?
Third.
Yes, thank you. Because 65 is greater than 55.9. So we're using this equation. If it's 65 miles per hour is the wind, it feels like 41 degrees. Any questions on that? Let's look at one more. For the non-extreme weather months, the electric company charges $7.10 plus 6.747 cents per kilowatt hour. Cents per kilowatt hour, that's your slope. Now this is in cents and this is in dollars. And that's why I wrote this here, because you need to have the same units. And when you're talking about a bill, it's going to end up in dollars. So you don't want to make the dollars into cents. You want to make your cents into dollars. So this I changed to dollars. Using up to 1,200 kilowatt hours and charges 88.6 plus 5.788 cents. Again, we'd convert it above 1,200. Write the function that gives the monthly charges in dollars. We have a fixed cost and a rate. Y equals mx plus b. So our first equation it's $7.10 plus 0.06747 per, and then it's up to you if you want to use X or K for kilowatt hours. So the cost is $7.10 plus 0.06747 times however many kilowatt hours we use. And that is for customers using up to 1,200 kilowatts. Now, we know we can't go below 0. So it's up to 1,200, but it wouldn't be a negative value. So it would be between 0 and 1,200. But it could equal 0. Technically, you could be gone for a month and not have any electricity on. Any questions on that part? Okay, go ahead and write the second equation when we're above 1,200. So did you get 88.06 plus, and then this was in cents, so I rewrote it to dollars, 0.05788x. And that's when x is greater than or equal to 1200. So my x is the number of kilowatt hours used. And my function is the monthly charge. Right, the function that gives monthly charge. And we converted everything to dollars, so it's in dollars. If we would have converted everything to cents, then it would have said in cents. Any questions on that part? What is the monthly charge if 960 kilowatt hours are used? I don't get this right. Well, decide which one it's in. Is 960 in the first row or the second row? Well, 960 is between 0 and 1200, so we use the first one. The $7.10 plus 0.06747 times 960. When you have these ones with all these decimals, it's best to keep all the decimals until your final answer. And then since we're talking about money, we'll round dollars and cents. 71.8712. $71.87. Any questions? If we use 1580 kilowatt hours, you want to look at your inequality first and see which one it falls into. 1580 is greater than 1200, so it's the bottom row. $179.51. Is that what you're getting? Any questions on those? Okay. Section 3.4. What it does is it looks at all through, well, we've learned the linear equation and we learned quadratic. We haven't learned the power function yet. A power function, x to a larger number than a 2. it usually, well, it either grows really fast or decreases really fast. We don't get into too much of doing it by hand, but you do need to know what the graph looks like so you're able to know if it's entered properly. There's an asymptote here, but it either grows real quick or drops. And that would be our power function. For finding the equations, Desmos is going to do it for us. Now you can use TI-83 or the 84. It's more work. You can also use Excel if you're comfortable with it. I prefer Desmos because uniformly it works better for everybody.
Wait, I'm confused. I thought a power function was when x was in the exponent.
No, that would be exponential function.
Okay, so
Yeah, if you have 7 to the x, e to the x, 5 to the x, those are exponential functions, where a power function is x to a larger power than 2.
okay.
We do get into these, I forget which chapter, but not this one. I think it's chapter 4. Okay, let's go on to Desmos. So bring Desmos up. A lot of the problems in this section, they'll ask you to make a scatter plot, which we've learned already. And then they'll ask for the linear equation, which we learned already. And then the power function and the quadratic function. And then we look at R squared to see which one is best fit. So we're going to use this first equation and we're going to do all these steps. So using the first table, and I typed these into Desmos already, so I wouldn't have to spend time typing. Okay, so I typed this first table in 3, 5, 7, 9, 4.7, 8.6. Okay. Need these equations. So go ahead. Remember to type in a table. You click here and then click on table. And then you just type your values in. To show all of this, you could click on the wrench. What I did was I went to the wrench. I like to start with -1 so it shows my axis line. If everything's positive, I start with -1. And then I saw this went up to 9, so I went to 12. I could have went to 9, but then the point's right on the line. You don't always get to see that one. So I went with 12. Then I looked at my Y values and I started with -1. This went to 17, so I went to 20. That way I could see all 4 points. Now to find the linear equation, we've learned this one already, and it's what you're going to do on your project. You can click here. This is x1 and y1. I want y1 equals mx1 plus b. Y, and then when you hit 1, it's going to put it lower. You don't have to worry about getting it in the lower score. Equals mx1 plus b. Okay, what did I get wrong? What happened to all my numbers? 4 point. And I need to. What did it do? Oh, I know, because I hit equals. I'm sorry. The biggest mistake I see, and well, we don't have a test in the in-person test, but on the take home, people send me, what did I type wrong? You cannot put the equal to here. Remember to use the little, you want the one that goes like this. And it's right next to your number 1 on your keypad. You hit shift and that button. So it's right next to your number 1. And then mx1 plus b. So our line, we look here, m equals 2.065 and b is a negative 1.565. So your equation, y equals m minus 1.565, oops, and don't forget to put your x. Mx, and then b was a negative, so I subtracted. My r squared right here, 0.9995. So that's your linear. Any questions on that? Looks like this one's off by a little bit here and there. And that's why it's not 1, because if r squared is 1, it's an exact linear equation. So remember, r squared is always between 0 and 1. The closer to the 1, the stronger the relationship. Closer to 0, the weaker. Okay, go ahead and try the quadratic. So when you enter the quadratic, it's y equals ax squared plus bx plus c. Wherever there's a y and an x, you'll use the 1. Now you can leave this one here and start another one. y1 and the little similar line. Ax squared plus bx1. Now notice I didn't put my 1. Plus, let's see. I can go back and put my 1 in. I'm using 1s for the subscript because my table is 1s. If your table was x sub 2 and y sub 2, then you'd use x sub 2s and y sub 2s. So we should be getting this, and here's our A, our B, and our C. So our quadratic, y equals 0.00625x squared plus 1.99x minus 1.37125. And r squared is the same. Any questions so far? The last one, the power function, y1 a little similar line, and then a x1 now to get the exponent, you can either use a caret, which is next to the 6, or you can go here and use the a to the b and put the b up there and come back down. Then it gives you your a and your b, and your r squared is a little weaker than the other two. So y equals a, which was 1.3. And the exponent was 1.16043. And r squared 0.9992. So on the next exam, the take-home portion, there will be one where you're given a table, and then you'll find each of the equations and tell me which one is a better estimate. We'll do another one, but is there any questions on that one? Everyone's getting them to come out. Okay. The second one on here. We have this table, and I typed it in. 4, 9, 11, 20, yeah. And then so that we can see our graph, I made it go from -1 to 10. Look at the x's. I always start with -1, unless there's negatives, then I go a little further negative. But business-wise, usually it's all positive. So it's going 1 to 6. I went -1 to 10. Go a little bit bigger than 6. And then the y's go from 4 to 45. So I went -1 to 50. And that way, then all my points, I can see them. Looks like a straight line's not going to be as accurate as one of the ones that bend. So I would think the power of the quadratic would probably be better than the straight line. Any questions on plugging them in? Remember, you click the little plus sign, click on table, and then enter them. Any questions so far? Okay, go ahead and find the linear equation, the quadratic equation, and the power function. So I put y1 similar to mx1 plus b. And notice r squared is 0.9388. So it's still strong, even though these points are not on the line. They're close enough that it's still a really strong relationship. Any questions on getting the straight line? Okay, go ahead and do the quadratic. y1 equals. Why did that? Oh, because I put an equal. I also like Desmos because it shows each line as a different color. Hmm. So, hmm. Oh, I'm typing that in the wrong spot. I'm sorry. Someone had one where it was not coming, like they're typing it in on Desmos, but then on my math lab, it's not giving the right answers. If that happens, send me a picture and send me a picture of the problem and a picture of what you put in, and we'll find out why, but it should work because it worked last semester. So you should be getting for the quadratic 0.9948. And then the power function. Y1 AX1 So if we look at the green one, it's missing a lot of points where the blue is closer to the points. And notice the blue R squared is 0.9948, where the power function it's 0.9866. So it is definitely not as strong, but they're still both strong. And they're both stronger than the straight line. So in some cases, when we're getting an estimate, it's better to use a quadratic or a power function. Are you going the right decimal places? That's another thing you want to check. And if you're plugging a value in, like for a story problem, use all the decimal places that are here and then round. I will. No. But if that's happening, send me a picture of the problem and what you put, and then I'll go on Desmos and give you credit for it. That's not, I don't want you to do it 100 times if it's not working, but I will go on and play with some problems too and see what's going on. And then I will let my math lab know. I'll send a message to Pearson. Your equation is right. AX to the B. It's the right formula because I looked it up to double check to make sure I was putting it the way the book puts it. But I will check that tonight. So it's the power function, not the linear. It's only the power function. Okay. What time is it? There's a story problem. I wanted to do one. I think it's this one. Let me. Page 226. Okay, so on this one, number 31. Again, I put the values in, but notice for X, I did not put 2000, 2010, 2020, because X isn't the year. You need to be careful. If we read here, it says, somewhere it says, create a scatter plot of the data with X equal to the number of years after 2000. So X is the number of years after 2000. Well, if we start with 2000, then it would be 0 because there's no years after 2000. All you're doing is subtracting 2000 from each of these. So the X, instead of being 2000, is 0. And then this one would be 10 years, 20 years, 30. So you want to be careful that a lot of times when it's years, X is not the year. And then Y equals the number of millions of Americans. So this is in millions. Any questions on that part? It says find a quadratic function that models this data. Report the model with 4 significant digits. So this is saying even if it's giving us 8 digits, we want to go 4 in our equation. So if I click on here, it wants quadratic. That's y equals ax squared plus bx plus c. This is an x1 and a y1. So it's y1 and then the little squiggly line. Ax1 squared plus bx1 plus c. Any questions on that part? And so you could see the line here. No, it only wants 4 significant digits. That could be. It doesn't mean 4 decimal places. It means 4 significant digits. So I 0.00. I believe you want to go. I don't know my significant digits. I didn't notice it said that. I just want to make sure I'm right. It's not coming up. I believe the zeros in the front are not significant. I want to double check that and then I'll send out an email, but that could be why you're having problems. And if it's saying to go 4 significant digits, not 4 decimal places. And I think that's what that said. Double check. 4 significant digits. So you have to be careful That doesn't mean 4 decimal places. Quadratic ax squared. And then b was positive 0.0, so 4 digits, 977. And then that 8 becomes a 9x. This is 4 significant digits. And then positive 4.0207. That would be 4 significant digits. So be careful if it says the decimal places or digits. Okay, so now on the homework, if it says round to the nearest thousandth, you're going 3 decimal places, not significant digits. So be careful which one it's asking for. We don't really get into a lot of significant digits. It's used in science, but in math, we usually just say thousandth, hundredth. And in business, we're usually talking about money, so everything is the nearest cent. But be careful on my math lab, sometimes they say the nearest dollar. So always keep an eye out for that. Okay, so this would be your equation. Let's see what else it asked, I forget. Oh, we already graphed it. How many Americans does the model predict will have Alzheimer's disease or other dementia in 2056? So we said this equation's a good equation. 2056. Another thing you have to be careful of then, remember X is the number of years after 2000. So we're plugging 56 in for X. That's weird. I wonder what happened. Someone's mentioning that the quadratics are also wrong. But you would plug 56 in for X. I will go on my math lab. I have another class next. But tonight I will go on my math lab and find out what's going on. And if you do run into any of those and you're doing it right, just send me a picture of it and I'll go on and give you credit for it. Actually, you don't even have to send a picture because I got to go in and look at it. No, send a picture of what your work because I won't be able to see your work. So send your work so I know you did do the problem. And then I will go on and give you credit for it. Because as long as you're doing it right, I don't want to take off, but I do also want to make sure you're doing it right.